Alright, so in 8.6, we have the example of a radical equation. We've simplified them, we've added them, we've subtracted them, we've multiplied them, we've divided them, but we have not actually solved them yet. So to solve radical equations, you must undo the radical using what's called the power rule. Which means you raise both sides, this should say sides, of the equation by the index. So whatever the index is, I have to put it to that power on both sides of the equation. Sometimes the resulting answer doesn't work when you plug it in, which means it is an extraneous solution. Which means for these problems, more than any of the other ones, you always have to check your answers, because if you don't, you're going to tell me you get 2 answers and you probably only get 1, or maybe you get none. And that's just because sometimes when you plug that number back in, it's not going to work. Some of these you're going to like. They're pretty straightforward and simple. Some of them are a little more complicated. So for the first one, what is the index of number 1? 2. Good. So if my index is 2, my first step, raise both sides to the power of 2, since the index is 2. So on the left, I'm putting this to the second power, and on the right, I'm putting 4 to the second power. What that does for us is, on the left-hand side, the square root, since it's an index of 2, is going to cancel off with the 2 up here. So I'll just be left with 5x plus 1 equals, so the whole purpose of raising it to a power is to get rid of the radical. And then on the right-hand side, what's 4 squared? 16. From here, this is a really basic Algebra 1 skill. We have to get the x by itself, isolate the variable, and then solve. So what would be my first step here? Good, subtract the 1. So we get 5x equals 15. Good, by 5, you get x equals 3. Now here's where I said you have to be careful, because maybe the answer is 3, and have to disregard that solution. So that's why on each one of these problems we're going to have to do a check. And I know you don't like checking your answers, but it's kind of important for these kind of problems. So we have square root of 5. Let's plug in x plus 1 equals 4. So we get the square root of 5 times 3 is just 15. 15 plus 1 is 16. So 4 equals 4. Is that true? Yes. So my final answer in the curly brackets is 3. And that's how you'll see it on a test. If it's multiple choice, they'll put it back in the curly brackets. So we raised each power, solve normally. Always check your solution. Definitely the most important part, because you can get an answer, but then if you don't check it and it doesn't work, you'll still get the wrong answer in the end. Number 2 is going to show us an example of one that would not be included. So number 2, and really you can figure out when something's based on if you have to do anything first. So in this one, I can't just square the left-hand side. I have to move the 2 over to the other side. So if I subtract 2 from both sides, so that's my first step, which is your additive inverse. We get square root of 5x plus 3 equals negative 2. Chances are, if you end up with a negative on the right-hand side, you're going to have at least one solution that's extraneous, because you can't take the square root of a negative. So because of that, you know that we will probably have at least one solution we're going to have to disregard. The index in this one is what? Good. Index equals 2. So raise both sides. So since my index is 2 and my power is 2, that's going to kind of cancel each other off. I'll be left with 5x plus 3 equals, is on the inside, so negative 2 times negative 2 is just positive 4. My third step will be to solve. Well, the first one would be additive inverse. Then multiplicative inverse. Getting the vocab back from the beginning of the year. So subtract 3. We have 5x equals 1. Multiplicative inverse, that means I'm dividing both sides by 5. And you get x equals 1/5. Here's that important part. Check. So I'm plugging this in, and yes, you can use your calculator if you want to. I'm not going to. Five times a fifth, this just ends up being 1, so I get the square root of 1 plus 3 plus 2. Check it, I plug everything back into the very original problem that they gave us, not the one that we changed. So we have the square root of 4 plus 2 equals 0. 2 equals 0. 4 equals, which in this case is false. Since it's false, this cannot be an answer, so I have to cross this one off. It's not going to work. And that's the only one I got, so my answer is going to end up being, don't put it in there, the null set. Which now, some of these you're not going to like very much because you are going to have to use factoring. Factoring, it's coming back with a vengeance. Factoring will never go away. Ever. It's like a plague. So, same first step, really. So, I don't have any adding or subtracting I have to do. The radical is all by itself, so I don't have to subtract anything off. So your first step, x of the radical, 2. So most of these are going to be 2 because usually that's what you solve, but we are going to have a couple where it's not. Those are actually easier than when they're not 2. So the index equals 2, so raised to power of 2. So I'm squaring the left, squaring the right. Now, what that means is since I have x plus 1 squared, that's going to end up being a binomial times a binomial, so I have to use the box method. So on the left, it's easy. I end up with 5 minus x. But this one, I end up having to do box. So we have x plus 1 and x plus 1 because this square means that there's 2 of them. I can't just distribute the 2 to the x and the 2 to the 1. It has to be x plus 1 times x plus 1. So I end up with x squared, x, and 1, which is just x squared plus 2x plus 1. Thank you. So now on the right hand side, I'm going to have a trinomial that it's equal to. So I have x squared x plus 1. Okay, from there, I'm going to have to do some of my inverses in order to get everything to one side. So get everything to one side. What? What about the box method? We could if you wanted to. Call that 3. And 2, use box method. That's kind of included in the fact that you're multiplying, but we'll put that in there so that you remember to do that. Now, the reason why I'm getting everything to one, subtract things out, is the fact that whenever I have an x squared, that means I'm going to end up having to factor. Well, next chapter, it's not going to be just factoring. It's going to be a couple other methods that you might like better. But squared in these problems, I know that I'm going to end up having to factor the answer. So I'm going to move all of my stuff over to the other side. I'll start with the 5. So I'll subtract 5 from both sides. So I'll end up with negative x equals x squared plus 2x minus 4. And then I'm going to add the so equals x squared plus 3x minus 4. Now that it's equal to 0, I can factor, set them both equal to 0, and solve. So my fourth step is to factor and solve. So I am looking at the two numbers to multiply to give me negative 4, but adds to give me positive 3. Good, 4 and negative 1. So x plus 4 and x minus 1. I set both of these equal to 0 now. So I'll have x plus 4 equals 0 and x minus 1 equals 0. So over here I'm subtracting 4 from both sides, and I get x equals negative 4. And over here I'm adding 1 to both sides, so I get x equals 1. You're going to have for both, yes. So check 1. Check. And yes, your fifth step is to check. Check both solutions. So check x equals negative 4. So 5, negative, negative make a positive, so it's 5 plus 4 equals negative 4 plus 1. Remember, I'm putting it back into the original where I'm putting it into before I have the blue stuff there, just the black writing. So I have the square root of 9 equals negative 4 plus 1, that's negative 3. Square root of 9 is 3. Does that equal negative 3? No, so that's false, which means I have to cross off my negative 4. Check. We're going to check x equals 1. So I have 5 minus 1, square root equals 1 plus 1. Square root of 4 equals 1 plus 1 is 2. And you're right, 2 equals 2, so this is true. which means x solution is my only one, so I'm going to put it in my curly brackets, and that's my answer. Okay. Next one's be basically the same kind of concept. So first one, don't be afraid. Okay? It'll be okay. But they don't. Not quite. First one, we have the index again is, what is it? 2. So index is 2, raise to power of 2. Sides, I'm putting it to the second power. You can tell right away that the right-hand side, I'm going to have to do what method to figure it out? Box method, right? That will end up being use box method to square right side, which technically is the same as the one that we did above, so you could just copy it down just so that you have it. So I have x plus 1, x squared, x, and 1, plus 2x plus 1. So on the left off, so I don't have to do anything over here, it's just 1 minus 2x minus x squared. On the right side, I have x squared plus 2x. Step 3, get every one side. Now, because I want to keep everything positive, I'm going to move everything to the right, squared to both sides. I'll take it step by step just so you don't get confused. So I'll have equals 2x squared plus 2x plus 1. Then I'll add 2x to both sides. Doesn't really matter which order you do it in. So we have 1 equals 2x squared plus 4x plus 1. Now subtract out your 1. So we have 0 equals 2x squared plus 4x. The 1's killed, so that's all I'm left with. Fourth step, factor and solve. Now this factoring problem is not a trinomial, which means I'm not going to end up having, like we did in the last one, I'm not looking for 2 numbers to multiply to a number and get the middle one. I don't have 3 things. So this one I'm just factoring out my GCF. So it's still equal to 0. What's in common between 2x squared and 4x? 2, and I can take an x out. So 2x comes out of both of these, which means I'm left with just a plain x here, because 2x squared divided by 2x is just 1x, plus 4 divided by 2 is 2, and then the x is canceled. I'm left with we factor out the GCF. I'm setting both of these equal to 0, just like we did in the last one. So I have 2x equals 0 and x plus 0.
Says you lost.
Lost you where? Can you try and help me out here?
I'm good.
You're not okay if you're lost. Divide by 2, you get x equals 0. Subtract 2, you get x equals -2. Final step is to check both answers. We'll start with x equals 0. Remember, I'm plugging it into the original equation. So it'll be 1 minus 2 times 0 minus 0 squared equals 0 plus 1. 1 minus 0 minus 0, so that's just square root of 1 equals 1. So 1 equals 1, that's true. I have one solution. Now I'm going to check x equals negative 2. So we have 1 minus 2 times negative 2 minus negative 2 squared equals negative 2 plus 1. You can put this straight in your calculator if you want to. But we'll have, order of operations tells us we have to do parentheses first, so this is going to end up being 4. And right here, that would come next, so negative 2 times negative 2 is positive 4. So we have 1 plus or minus 4 equals 2 plus 1, which is negative 1. The 4's end up canceling each other off, and we get square root of 1 equals negative 1, which is not true. It's off my negative 2. That's not going to be an answer. So my final answer is just 0. So yes, that one took a little bit more work than ones that we've done in the past, but all the steps continue. So you take the index, raise it to both sides. Sometimes you have to do box method, sometimes you don't. Get everything to one side, factor, which is what this step is. Factor out the GCF, solve, check, and then state your final answer. Now on the back, I'm actually going to have this as an extra credit problem, because after doing it yesterday on my own, it is a lot of work. There are some confusing parts to it, but I think there are definitely that are able to do it, so I'm going to allow you to do it for extra credit, and I'll give you a couple extra points on either the quiz or the test or something. So if you go back and do this at some point, make sure you show it to me, but yes, you can do that for extra credit. But I don't think that it's necessary for this coming test, because you're not going to have something this complicated on the test for everyone, so I don't want to even confuse you more than you might already be. Okay, so number 6, we're going to jump right down to there. And this time we don't have an index of 2. So my first step, the index is, yes, good, 3. So raised to a power of 3. So on both sides, I'm putting it to the 3rd power. The 3's end up canceling each other off, so I'm just left with 2x plus 7, 3x minus 2. Second step, use so your additive inverse and your I'm going to start 2x from both sides. I don't care where you start. So 7 equals x minus 2. Then add 2 to both sides. So 5 equals, 9 equals x. So we have 9 equals, check it.